The purpose of this video is to provide an example of an annotation of an independent samples t-test. We're going to be focusing on looking at the differences between means on the Woodcock-Johnson 23 Roche-Wright scores by gender. The first thing that we're going to be looking at is our sample size, and you can see that we have 884 males and 839 females. The mean for the males was 394.1686, and for the females was 394.0822. When we subtract 394.0822 from 394.1686, we get a mean difference of 0.08631. The question that we have is whether or not that observed difference is significantly great enough to have occurred by factors other than random sampling fluctuation alone. The first thing that we're going to do as we look at this is to determine whether or not we have homogeneity of variance. This is a critical assumption of independent samples t-test, and as long as that value right there of 0.172 is greater than 0.05, we can accept the assumption of homogeneity of variance. So the first rule that we're going to follow is if Levine significance is greater than 0.05, we accept homogeneity of variance. The second thing we're going to be looking at is whether or not we have a significant t-value. To determine that, we look at our observed difference, which we already have established as 0.08631. The difference that would be due to random sampling fluctuation alone, that is the standard deviation of the sampling distribution, is 0.73019. The t-value is a ratio that is based on the ratio of 0.08631 divided by 0.73019. The observed difference divided by the amount of difference that we would expect it typically due to random sampling fluctuation. When we divide 0.08631 by 0.73019, we get a t-value of 0.118. That t-value is a ratio, and it tells us that the observed difference of 0.08631 is about 11% or 12% of the difference that we would expect to due to random sampling fluctuation alone. Unless that value approaches 200% or a t-statistic of 2.0, we're almost always going to fail to reject the null hypothesis. In this case, we fail to reject the null hypothesis because our observed significance level here is 0.906. 0.906 tells us that a difference of this size of 0.08631 would have occurred due to random sampling fluctuation alone in a situation in which the samples were drawn from a population in which the null hypothesis is true. That difference would have occurred due to random sampling fluctuation alone almost 91% of the time. So we fail to reject the null hypothesis in this case.